Hello everyone. In this session, we will give you an introduction to classification. So let's get started. In machine learning, classification is a supervised learning approach which can be thought of a means of categorizing or classifying some unknown items into a discrete set of classes. Classification attempts to learn the relationship between a set of features variables and a target variable of interest. The target attribute in classification is a categorical variable with discrete values. So, how does classification and classifiers work? Given a set of training data points along with the target labels, classification determines the class label for an unlabeled test case. Based on the default existing data and features plot is made with classes. This is the training phase. Now a trained dataset, the k nearest neighbor algorithm can be applied. Classification can be applied to a variety of use cases such as an email spam detection, an identification of objects such as cats or dogs, a customer churn for telecom industry, and so on. Supervised algorithm works on this function, that is y equal to f of x. Now let's discuss KNN. The k nearest neighbors, or the KNN algorithm, is a supervised learning method used for classification and regression problem predictions. The output of KNN in classification of the unknown target data point based on the k nearest neighboring points from the training data is the majority of the k points. Now let's discuss the steps involved in this algorithm. Firstly, a default value of k is picked. The distance of all the data points in this training set is computed using Euclidean distance method, which we already know. The distances are then sorted. Now, for n equal to 1 until n equal to k, the search for k observations in the training data that are nearest to the target is made. The prediction response is made based on the maximum number of hits or the most popular hits for the classification based on the above search. If the classification is insufficient or if it is ambiguous, then the value of k is increased and the process is repeated until majority of the outcome is observed. Now, we are here going to develop KNN algorithm from scratch that shall mimic the machine learning frameworks like TensorFlow or scikit-learn. The goal here is to adapt core ML skills that would be expected in a typical technical coding interview. Firstly, we import the math library in Python. Note, we don't use any framework here as scikit-learn or TensorFlow. We are going to write a simplified version of KNN from here onwards. We shall define a KNN function that takes three parameters: a set of points that are plotted across x and y axis of the scatter plot, the target point, and the default value of k, which is set to 5. This method implements a simplified version of k nearest neighbor algorithm. The training set is classified into three classes, which is 0, 1, and 2. While the input test set is required to be predicted as belonging to one of these classes. Now the parameters are points, dictionary of training points having three keys 0, 1, and 2. Each key have a list of training data points belong to that. PT, a tuple test data point, is in the form of x and y. Next is the k, which is a number of nearest neighbor to consider. We keep the default value as k equal to 5 as mentioned before. For every point, the scatter plot, we compute the Euclidean distance and save them as a tuple of form, which is distance and group, in the distance list. Further sort them by distance. We now initialize the class counters class 0, class 1, and class 2 to 0, and then find the count of each class groups based upon the distance computations. The function then finds the maximum classifier for a given k and return the highest class. Now call the driver function from main to invoke KNN. A dictionary of training points having 3 keys are created. And then plot the graph of the point with red, green and purple colors. 0 termed as red, 1 purple, 2 green. With k equal to 6 and points of 2.5, 7, we predict this data classification point as purple. Thanks for listening and watching.